To graph this parabola that's in vertex form, let's begin by identifying the vertex and graphing it. The x-coordinate of the vertex will always be the opposite of the number inside a parentheses. So since it's +1, the x-coordinate will be -1. Now the y-coordinate of the vertex is the same as that number on the end. So the y part is -3. Plotting that point, let's move back 1, down 3. Now that we have the vertex, we want to plot a few more points. I like to choose x's that are close to the x-coordinate of the vertex. +1 is pretty close to -1, so let's substitute 1 in for x. To evaluate, we want to follow PEMDAS, so doing what's inside parentheses, 1 + 1 is 2, followed by exponents, and 2 squared, 2 times 2 is 4. Then what we have left is 4 minus 3, which is 1. So when we substituted 1 for x, we got out 1 for y. Let's plot that point, right 1, up 1. Now in every parabola, there's a line that splits it in half. So if we plot a single point, if we just reflect it across that line, we kind of get 2 for 1. So I'm going to move that across that center line, and we have another point. If I would have substituted -3 into the original equation, I would have also gotten +1. But it's easier just to reflect it across that center line, which is called the axis of symmetry. Let's go ahead and select another x to substitute so we can plot one more point. I like selecting numbers close to the x-coordinate of the vertex. So 0 is pretty close to -1. Substituting 0 in for x, I have this equation here. Let's follow the order of operations, doing what's inside parentheses first. 0 + 1 is 1. Next, exponents. 1 squared is 1 times 1, which is 1. And finally, 1 minus 3 is -2. When x was 0, y is -2. So let's plot that point, right or left 0, down 2. We can use that axis of symmetry and jump across that and get an extra point. Or we could have substituted -2 in for x and simplified, and we would have also found the y-coordinate to be -2. With all of these points, I'm sketching in the parabola, and our graph is complete.